Let's start now with chapter 35, which is talking about electric circuits. Now, what is an electric circuit? Now, imagine now you are in the class or at your home, press the switch here. When you press any switch, you turn on the lamp. So when you press the switch, there's a current, that means you allow the current to start passing through the wires to let a lamp working. This is, we called it an electric circuit. So what are the objects that can you see that contain an electric circuit? In this electric circuit, what did you see? You see a source of electricity, such as a battery. You see also a wire that's connect between the lamp and the switch. And this type of wire, it must be conductor. So that's why we say conducting material. And also we see a light bulb, which is a component that we use, that we see the electric in it. It could be a light bulb, it could be a whiteboard, it could be a hair dryer, it could be microwave. So there's a components of an that we use it on the electricity. And the last one, the switch. The switch here, we can turn on or turn off the circuits. Thus we can break or to break the circuits. So the four components here in a circuit, they are a wire, a light bulb, switch, and a battery. This is the most components of an electric circuit. Now, let's see now how they draw the electric circuit. Let's see here that's how to drawing the circuits diagram. Electricians, architects, and engineers may need to draw diagram of electric circuits. They need to draw. They cannot every time draw the resistance, draw the light bulb, draw the switch, draw the battery. They need to use symbols. So to make diagrams easier to understand, electric circuits using by symbols, such as this one here. And look at this one. This is a battery. They draw it like this, where this is and the wire that is connecting between the battery and the light bulb, we draw it like a straight line, and the light bulb, we draw it like this symbol here. This is an electric circuit. It contains a battery, wire, and a light bulb. Now, is a circuit a closed or open? Oh, it is supposed to be closed or open to work. Closed path or open path?
Closed path.
It must be closed path. Bravo. So a circle, to can say that it is working, we have to say it is closed back, a closed path. So let's talk about the circuit symbols here. This is a straight line, which is a connecting wire. The lamp can use it sometimes like this, or some of the books tell you it's like this. This is the battery. This is the switch. This is switch, that means it's open, so the circuit will not work. But if you close it, it means it will work. Now the electric motor, it's not with you. The resistor, you need it. Yes, this is how we will draw the resistor. It's in zigzag way. This is the ammeter, that's measure the current, and this is the voltmeter, that's measure the volt. So this is the most important for us. This one and this one, no. So this is the straight line, is a connecting wire. This is a light bulb or lamp, battery, switch, voltmeter, ammeter, and resistor. These are the most important for the symbols for us in this book here. Now, let's have this example here. This one here, we have a battery or we have a cell. As we know, it has a positive and it has a negative. Now, this battery is connecting with a switch that is open or closed to allow the currents move in it or pass through the circuit. This is switch on now, light, or it's connecting with the bulb. What does it mean? That means if I switch on, if I turn on the battery, the key, that means I allow the current to pass from the battery and let the bulb open. But if I open it, if I switch off, that means I will stop the currents passing through the wire, so I will not allow the lamp to work. And this device here, which is an ammeter, that's here to measure the current. And as you see here now, the ammeter connected in a series. Later on, I will tell you about this. So let's now see here, how can we represent it? Not in the engineers and electrical engineers, if they need to make this type, they cannot draw a battery, draw an ammeter. It takes time. So they use a symbols. What do? They say that instead of drawing an bulb, a light bulb, we have to use to make like this. This is mean a light bulb. And instead of this ammeter, let's make a circle and inside it write letter A. This is meaning a meter. And here we have a switch. That's mean this switch is open. And we have a battery. Now, look at here. The negative sign on the negative for this battery, we write it as this small line. And the longest one, it's mean the positive side. So this one, it's mean negative positive, and this one, it's mean positive negative. The longest one is the positive. Be careful. So this is now and then we have to connect between them using a wire. This is how can we represent the circuit. Is it clear?
Yes, teacher.
Now, so what is an electric circuit? Electric circuits are made up of electrical components, as we said before. These are the components are the light bulb, the electric cell or a battery, connecting wires, and this is the board that holds the circuit on it. As you see here, this is a circuit. Now, electric circuits are made of electric components, and they have, these components are joining to each other. That's mean the light bulb are joining the electric battery with a wire, and the electric battery join the light bulb with a wire. So this make it a closed circuit. That's mean when I switch on the lamp or switch on the key as an example, I will allow the battery to come throughout the current, sorry, to come throughout the battery, let the light bulb work on. But if we have it as open circuit like this here, imagine now, I forget now to connect between the battery and the ampere. The circuit will not work. In this case here, the circuit will not work because it's an open path. It must be a closed path. When we have a closed circle, so we say that the electric circuit can work. Now, let's see now if we have an incomplete circuit. We didn't connect between the all devices here. Or I have a light bulb, I have an ammeter, I have a wire, but I don't have a battery. So how the circuit will work? This is an incomplete circuit too. Or if I have like a battery, if I have a circuit, if I have an ammeter, but there's no light bulb, this is not a circuit. So any incomplete circuit, we called it an open circuit. Look at the first example here of the first figure. We have light bulb, we have a battery, but we don't have here a connecting wire. Since there's no connecting wire, so I will say that this is an open circuit. Look at the second one. Yes, there's a wires that connect around a circuit, but here there's no battery. There's no source for the electrical energy. So So we have to say that this is also an open circuit. So both of these circuits here, if there's no wire, if there's no source of energy, so I will say that this is an open circuit, since it is incomplete. If it is completed circle, it will be an closed circuit. Now, so an electric current flows only if there's a source of electrical energy, and it must be a closed circuit. So if it is closed, if there are wires that connect between all the elements, and we must have a source of electrical energy. If we don't have an electrical energy, we will say that it is an open circuit. If there's no wire, we have to say that it is a closed. It is an open circuit. So to let an electric current flow, to let an circuit working, it must be closed, and we must have a source of electrical energy. If you have an ammeter, light bulb, wires, you connect between them, you make it closed, but there's no source of the electrical energy, there's no battery. So how the light bulb will work? It cannot. How the current will pass or will flow through the wires? It cannot, because there's no a battery. So to make an electric current flow, you have to make it as a closed circuit, and we must have a source of an electrical energy, such as the battery or any example or generator or so on. Now let's talk about the switch, which we say that it is the symbol. This is the symbol of the switch. This is, and imagine now. This is switch. When I say that the switch is open or closed. Now, the switch, which is at our home, it's come like this one here. This is the main switch that's used in our building. Now, this switch is used to open or close the circuit. What does it mean? That means if I have this one here as an example. If we have here a battery, if we have here like a light bulb, and if we have here a switch. Now, look at this one here. Since the switch is open, so it make it, so in the switch open, so it's make it an open circuit. So when the light or the current pass through the wire. When it comes here, it's so that the switch is open, so it will stop to flow through the wire. So the light bulb will not work. But if we close it, imagine now you close it. So what will happen? When the current will come here, they found there's no gaps, so it will make the light bulb work. So when the switch closed, so we have a closed circuit, so that's make the light bulb work. So the components or the part that is used to open or close a circuit, which is a switch. Now in our building, this is the main switch that we use. In the circuit board, this is the switch that they used. That's it. Do you have any question?
No, teacher.
No, teacher.